Hello students, and welcome to Chemistry B. I'm Miss Slate, and today we're going to be talking about the behavior of gases and the gas laws. So this note set is essentially going to summarize everything that we talked about with the labs that we just did, as well as walk through some practice problems. So first up is Boyle's law. Boyle's law is the relationship between pressure and volume, where the pressure of a gas is inversely proportional to its volume. And the equation that we use for that is P1V1 equals P2V2. At the particle level, when you decrease the volume, the gas particles have less space to move around, and therefore they're going to collide more often with each other in containers. And gas pressure is the result of particle collisions. So if there's more collisions, we get a higher pressure. Second is Gay-Lussac's law. And Gay-Lussac's law relates pressure and temperature, where the pressure of a gas is directly proportional to its temperature. So we know that when you increase the temperature of a substance, particles will move faster. Well, if particles are moving faster, they are going to collide more. And again, more particle collisions means more pressure. The equation that we use for this is pressure 1 divided by temperature 1 is equal to pressure 2 divided by temperature 2. Now, something to keep in mind, this equation and this relationship only holds true if our temperatures are in units of Kelvin. So if we are given our temperature in Celsius, we need to convert it to Kelvin. But it's a very simple calculation or conversion. To get your temperature in Kelvin, just add 273 to whatever the Celsius temperature is. But anytime we're working with gas law calculations and temperatures involved, we need to convert our temperatures to Kelvin. Third is Charles' law, and Charles' law relates volume and temperature. So when the pressure of a gas is constant, the volume of a gas is directly proportional to its temperature. And so the equation we use for Charles' law is volume 1 divided by temperature 1 is equal to volume 2 divided by temperature 2. And again, this is because of thermal expansion and contraction, right? So when you warm up a gas, the particles move faster and therefore get spread farther apart, increasing the volume. Again, though, just like the previous one, anytime we're dealing with temperature, it must be in units of Kelvin. So let's look at an example problem here. So first off, our question says, what is the pressure of a fixed volume of gas at 30 degrees Celsius if it has a pressure of 1 atmosphere and 15 degrees Celsius? Well, when we're solving these problems, we're going to use the guess method of problem solving. So the first thing that we're going to do is we're going to write down our given information. And our first one is that our temperature 1 is 30.0 degrees Celsius. Our pressure 1 is 1.11 atmospheres. And our temperature 2 is 15.0 degrees Celsius. Our unknown in this case is our second pressure. So P2 is what we're trying to solve for. Now, before I do anything else, I'm going to automatically convert my Celsius temperatures to Kelvin. So I think that's a good habit to get into. So to convert to Kelvin, I just need to add 273 to each of them. All right, so I've got my givens with the temperatures converted to Kelvin, and I know my unknown is P2. Well, if I'm working with pressure and temperature, that means my initial equation is going to be P1 over T1 equals P2 over T2. Now, at this point, you have a choice to make. You can simply substitute in all the numbers we have and then solve for P2. or you can rearrange the equation first. Personally, I like to rearrange the equation before I substitute. So the first thing I'm going to do is get P2 by itself by multiplying both sides by T2. So the equation I end up with is P2 is equal to P1 times T2, all divided by T1. And now I'm going to do the substitute and the solve. So I'm going to plug in all my numbers. Now, doing this whole process of using the guess method is really important in these ones, especially when we're doing the gas law calculations, because unless you keep very good track of what's T1 and what's T2, it's very easy to get those numbers mixed around. And that's probably the number one mistake that I see people making. But if we write out what all of our givens are really clearly and write out what our equation should be, it's much more difficult for us to mess up numbers like that. Once we've substituted though, the last thing to do is just solve. And rounding to significant figures, we get an answer of 1.06 atmospheres. And I knew I had units of atmospheres because my units of Kelvin were going to cancel, leaving just atmospheres. Let's look at another example. So in this one, it says a gas has a volume of 2 liters and is at a temperature of 20 degrees Celsius. What is the volume of the gas if the temperature is increased to 25 degrees Celsius? Again, we're going to solve this using the guess method. So the first thing I'm going to do is write down my givens. And I'm given a volume of 2.00 liters, a temperature of 20.0 degrees Celsius, and a second temperature of 25.0 degrees Celsius. And my unknown in this case is the second volume. What is the new volume? Well, again, first thing I'm going to do before I think about anything else, convert Celsius temperature to Kelvin. Then I'm going to figure out my equation. Well, if we're dealing with volume and temperature, I know my initial equation is volume 1 over temperature 1 equals volume 2 over temperature 2. Again, I like to rearrange my equation before substituting, so that's the first thing I'm going to do, is I'm going to make this solved for V2. And so my equation comes out to volume 1 times temperature 2 divided by temperature 1. Last step of the guess method is substitute and solve. And rounding to significant figures, we get 2.03 liters as our second volume. Now, one thing we should have noticed is that all of our gas laws are very similar, and they're all relating the same 3 things: pressure, volume, and temperature. Because of that, we are actually able to combine all 3 of those gas laws into just one gas law equation that we call the combined gas law. So basically what the combined gas law is doing is it's taking Boyle's law, Gay-Lussac's law, and Charles' law and combining it all into just one equation. And so in the combined gas law equation, we have pressure 1 times volume 1 divided by temperature 1 equal to pressure 2 times volume 2 divided by temperature 2. So let's look at an example of a combined gas law problem. So this one says a gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. If the temperature is raised to 80 degrees Celsius and the pressure is increased to 440 kilopascals, what's the new volume? Again, guess method, write down the given information first. We are given an initial pressure of 110 kilopascals. We're given an initial temperature of 30.0 degrees Celsius. We're given an initial volume of 2.00 liters. They then tell us the new temperature is 80.0 degrees Celsius, and the new pressure is 440 kilopascals. And what we need to figure out is the new volume. Again, before doing anything else, I'm converting my Celsius temperatures to Kelvin. My equation, so again, the combined gas law, pressure 1 times volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. So again, just like I did before, I'm going to rearrange the equation before I substitute and solve. But you could, just like always at this point, substitute and then start solving. So I get from my equation, the second volume is equal to pressure 1 times volume 1 times temperature 2 divided by pressure 2 times temperature 1. Now that I've got that all arranged, I can just substitute and solve. And we get a new volume of 0.58 liters. And that's how we'd go about using the combined gas law. Same process as the other gas laws, just we have a few more variables to work with. So let's do one last example with the combined gas law. So we've got a sample of nitrogen gas stored in a 500 milliliter flask at 108 kilopascals and 10 degrees Celsius. This gas is transferred to a 750 milliliter flask at 21 degrees Celsius. What is the pressure of the nitrogen in the second flask? Again, first thing, writing down our givens. First volume, 500.0 milliliters. First pressure, 108 kilopascals. First temperature, 10.0 degrees Celsius. Second volume, 750.0 milliliters. Second temperature, 21.0 degrees Celsius. And we are trying to figure out what the new pressure is. Next thing, convert Celsius to Kelvin. Then we're going to deal with our equation, right? So combined gas law equation. This time, I need to rearrange my combined gas law so that I'm solving for pressure 2. So my second pressure is going to be equal to pressure 1 times volume 1 times temperature 2 divided by volume 2 times temperature 1. And now we can just substitute and solve. And we get a second pressure of 74.8 kilopascals. And that's how we do calculations with the individual gas laws and the combined gas law.